Good evening, Sanjay.
Okay, my screen is visible, right?
Yeah, it is coming. Yes, come.
Okay, so Max contact. Mm. So first we'll see 2 cos 1 max, right? So what is 2 cos 1 max? So that there will be like there will be one select line. And this will be I0 and this will be I1 and this will be output, right? F. So
So in MUX, there is one output.
yeah, only one output.
Select lines could be multiple, input could be multiple,
Yeah.
output will be only one.
So yeah, correct.
So 2:1 means two input and one select.
Yeah, 2 input, 1 select. So if S equal to 0, if S equal to 0, I0 will be selected,
Yes.
and S equal to 1, I1 will be selected, right? So what will be the final expression? Final
S bar
expression
I0 and SI1.
is bar I0 plus S I1, right? Now, suppose you want to mm, do A plus B using first, let's simply do A into B. Suppose you want to be 2 input, like NAND get using 2 cross 1 multiplexer. So can you do how? Suppose you want to do A dot B using 2 cross 1 multiplexer. So just try. I'll wait 1 or 2 minutes. How you can solve?
Keeping the 0, 0 and 1 as B and using select line A.
Okay. So you want to the select line will be A, and it will be 0, or what do you want to say?
0,
And this will be
B.
yeah. Yeah. So it will be A dot B, right? So it will be if you so it will be A bar dot 0 plus AB. A bar dot 0 equal to 0. So it will be AB. So A dot B is equal to now you want, if you want to implement or get 2 input or get using 2 into 1 multiplexer. So
Yeah,
how
yeah.
you can do it?
So before this, see, here we are saying the input 0.
Mm.
There's input 0 for 0 select line and input B for 1 select line.
Ah,
Correct?
yes.
And the selector is A.
Mm.
So this A also is coming as an input from somewhere.
Oh yeah, A are you giving like 0? A can be 0 or 1, right?
Correct?
So A you can write A bar, right? So 0 means A bar, right?
Yes. So where do we use this MUXM? I
Like
mean,
suppose
this is a part of some element of some circuit or what?
Yeah, suppose there are multiple select line, like, and if you want to choose one, then you can use. Suppose there are multiple, you can say that,
Inputs.
yeah, multiple inputs. Suppose multiple TV channel is there. Suppose you want to select one channel,
Mhm.
then you can use multiplexer.
So suppose an earlier day it used to be like manual. We had to select using the knob. That was not some kind of multiplexer concept.
Earlier days, which
So
mob means?
yeah, much earlier when we used to select channel by turning the knobs, not using the remote.
Yeah, so I think that is like multiplexer concept. So if there are multiple channel is there, so you want to select one.
Mm-hmm.
So I think nowadays, like many is like in the, if you using the remote also, now some multiplexer concept in the is there. Like concept is there, so there is multiple select line. You want to choose one.
Correct.
Okay.
So
Now
for TV remote, it will be only 2:1.
there is 4:1 also multiplexer.
4:1.
4:1 also. Then there is a 8:1 also, and 16:1 also.
Okay. And
Now
two select lines are also for A plus B I'll try.
yeah, suppose you want to y equal to a plus.
One input will be 1.
Yes,
That will be A.1.
yes. Suppose this is a and this is 1, then
So this will give A.
yes.
So A B. But A plus B is like A bar B bar whole bar.
So we know that a plus
A plus A bar B is equal to A plus
b
Correct.
plus b, right?
B.
Sorry,
A
Yes.
plus A bar B.
A per B is equal to A plus B. Correct.
so we can give b, right? So it will be a bar b plus a. So it will be
Plus B.
okay. Suppose now it's now suppose you want to implement not get. So I will implement
1 0.
1 and 0, and it will give a. So it will be a bar dot a dot 0. So it will be a bar. Right. Okay, now let's do 4:1 multiplexer. So 4:1 multiplexer, there will be 4 select line, I0, I1, I2, and I3, and there will be 2 S1 and S0, right? So S1 and S0, and both are 0. I0 will be selected. Both are like 0 and 1
Why we call it 4:1?
because 1,
1 is output. So it is always number of inputs and 1 output.
yeah, correct.
So then number of select lines will be log input to the base 2.
Yeah, log to base whatever the input, and we have to take ceiling here.
So it cannot be like there are 4 inputs and only 1 select line.
No, it cannot be because we have to like with the help of 1 bit, how we can identify 4 things, right?
Correct.
We can identify 2 things, 0 and 1.
Correct.
1 0, it will be I2, and 1 1, it will be I3. So to final expression will be S1 bar S0 bar I0 plus S1 bar S0 I1 plus S1 S0 bar I2 plus S1 S0 I3. This will be the final. Right. So this is the multiplexer concept. So if you like in Anthem, like we'll be asking about the mainly 2:1 multiplexer.
Sorry?
In Anthem, we'll be asking like mostly 2:1 multiplexer, and maybe like 4:1 multiplexer. Like if you know the concept, then you can easily
Mhm.
doing the question. Okay, this is the multiplexer concept. And what do you want other than?
That number of how to find minimum number of NAND gate or NOR
Okay,
gate,
that's one.
such kind of things. I mean, yeah, some innovative thinking might be required to reduce the from 5 to 4.
Okay, so let me do some question. Maybe previous year question that will be previous year. I think we one question is there. So let's see. This one. Okay, I got that question. Okay. Let's draw that. Let me draw my thing. Okay. So let's draw ABC. So this will be First I'm doing the timing diagram, then after that we'll sum. One, two, three, four. Right. Right. Now okay. Suppose this is the timing diagram, and suppose that we have only three input NAND gates. And suppose you want to represent this timing diagram using the three input NAND gates. Then what is the you have to find what is the minimum number of NAND gate required. So how to approach this problem? Suppose these are the three input A, B, and C, and this is the output. Y is the output. So how to approach this problem? Anyone?
We can do K-map.
Yeah, we can do also KMF, but you can see that only
Okay,
zero,
yeah,
only
0 is
zero.
there when all others are 1.
Yeah. So maybe we can take POS, right?
Yeah,
Because only 1 0 is there, right? So what will be the output? Then what will be the expression, like final expression? So POS means if 1, then you have to take bar, right? So A bar plus B bar plus C bar. This will be the final expression if you take POS.
yes, sir.
Now, okay, now remember the NAND gate, right? So NAND gate means,
No, this POS, come again, please.
okay, you can see that
Yeah,
only,
Y is high only, and only one time it is low.
yeah. So if we find POS, we have to find only one time expression, right? You have to find only this, right? You have to does not care about the other because only one time low, right? So we can take
Correct.
POS. So it will be like time. It will be like less time required, right? So calculating the final term.
In POS, we take one as, zero,
Yeah.
a complement.
Yeah, correct. Right. Now, if you remember the NAND gates A and B, so what will be the output? Y equal to A dot B complement, right? Correct.
Yes.
If we apply De Morgan's law, it will be A bar plus B bar. Correct. Right. If we apply De Morgan's law,
Yes.
now here you can write A dot B dot C whole bar.
Two NAND gates coming like.
Yeah. Now you can write here, right? So you can write like that, right?
Yes.
We have a 3 input NAND gate, right?
3 input NAND. Okay.
Yeah, so we can put like that.
Thank you.
A, B, C will get A dot B dot C complement. So like this type of trick will be there. So you can there is one trick like that. You have to apply De Morgan's law. Then after that it will be easy. One trick is you have to find the POS, like it will be less time required. Then after that you have to again one trick is required. So this kind of question will be there. This is the like last year quiz one question, not this one, last year quiz one question. You got it? This question.
Yes, yes.
Let's see the another question. If like any n-term question is there, then we'll solve. N-term. Okay, another question I found. Let me. So let me write a 1-bit comparator takes 2 inputs input bits and outputs. Take 2 inputs and output 1 if they are equal. Output 1, this is 1 if they are equal and 0 otherwise. We have to find what is the minimum number of 2 input NAND gate required. 2 input NAND gate required to design this circuit. Right. So, like question understand, like did you like understand this question?
Yes, yes. Input 0, 0 or 1, 1, it will be 1, otherwise 0.
Yeah. So let's draw the truth table. So there are 1-bit comparator is there. So it's A and B.
So it's NOR gate.
Yeah.
Sorry, X mode.
So both are 0, 0. If they are equal, then it will be 1. If they are not equal, then it will be 0, 1, 0, 0, and 1, 1, 1. So this is XNOR gate, right? Y equal to A not B. So how many NAND gate required for XNOR? It will 5 NAND gate required.
5, yes. Yeah, that is something remember.
Yeah. So it's like you have to remember like XOR 4 gate is required. I
4
think.
gate and XNOR 5 gate.
Yeah, that will be sufficient for enter. Nothing new will be asked. So this time of tricky question will be asked, like not like that hi-fi funda.
So if any, I mean, yeah. So these things are like handy to remember. So any, I mean, list of such things is available or compiled somewhere. We can go through.
Yeah, maybe like
Or few are there in the lecture videos only.
that things are sufficient. Maybe like I'll create one cheat sheet and I'll share to you. That will be good. Maybe I'll create one.
Thank you.
Yeah, maybe in a doc file or maybe PDF file, and I'll share to you. And let's see other question also, if any other question is there. Okay, that is one nice question, previous year question. So question was, which of the following Boolean function can be universal get? Option 1 is y equal to a plus b. Option B, y equal to a plus b bar. And option 3, y equal to a bar b. And option 3, y equal to a jar b. So you have to find which of the following can be universal get. Like universal like function, or you can select. So which of the following function we can derive all the three gets. Like universal means like we can derive OR get also and NOR get also. Sorry, NOR not. OR gets, AND gets, and not get, right? So which of the following? So in note like 0 and 1 inputs are available. So how to approach this problem? Anyone? So you can see that y equal to a plus b. OR get cannot be universal get, right? Correct?
I mean, or is a part of universal.
Yeah, but it cannot be. It cannot derive this function. You cannot derive others get, right?
Yes,
Yes.
sir.
And also like JOR get we cannot derive other get, right? We can
How we can say that about ZOR? I mean, how?
JOR we cannot, because
A bar B plus AB bar,
yeah, so we cannot derive.
because it is also a form of OR only, because
Yeah,
plus
so
there.
yeah, so we cannot this two can be eliminated, right? Okay. Now you have to check this option. Now A plus B bar, right? Okay. So okay, so how you can do? Yeah, this is like universal got or not? Anyone? Like try to think, like I'll maybe wait 1 or 2 minutes. Try to think. Will be like your thinking skill will be increased.
No, we are giving 0 or 1 as inputs to A and B.
Yes, 0 we can give input. Like
So
say
if we make the truth table for AB and B bar, then it becomes A plus B bar becomes 1 0 1 1.
okay, so let me I give We have a function y equal to a plus b bar, and we have two inputs, a and b, right?
Mm-hmm.
So if we give a equal to 0, and if you are giving b, we'll get b bar, right?
Correct.
We got not get, right? Now, if we get input a and b bar we got, right? So if we get b bar, we'll get a plus b, right? We got OR get, and with the help of two get, we can make NOR get, and we know that NOR get is a universal get. You got it, this concept?
Plus B bar happen. Then B bar is there. So NOT get and OR get we created.
Yeah.
And
So
using you combining them, we are getting NOT gate, which is universal gate.
yeah, so we can say that this is a universal, right?
How about AND we didn't look for?
Then using the NOR, we can implement AND get also.
Further after that. Okay.
Yeah. Okay, now let's see y equal to a bar b. So this will be the correct answer. So now let's think about the creating NOR get or NAND get, right? So suppose we're giving b equal to 0, we are giving a b equal to 1, a bar b, where b equal to giving 1, so it will be a bar, this will be non get, right? And suppose this you have to get NAND get, right? So so how we can do?
Giving a bar comma b,
A bar comma b, so what will get?
it will be a bar bar dot b. So it will be ab.
Yeah, a bar bar. Can you please tell one? A bar.
Just like we did for OR get, say doing the same thing for AND, not AND get.
Yeah. So yeah, it will be giving. Yeah. So it will be giving. Yeah, it will be a bar. So a dot b. So see, we are giving only a, right? So it will be right. So we are getting AND get. So with the help of AND get, and this is not get, we can create an AND get. So this is
Okay. So NOR gate is universal and NAND gate is universal.
yeah, correct.
And those are the basic building block we can find using these.
Yeah.
But
Yeah.
why, if A plus B bar we can use, why not A plus B? Something.
A plus b, using like only we can like see a plus b we cannot create other basic gate, but NOR gate we can create other basic gate, right? And NAND gate create other basic gate. So suppose this is NOR gate, right? A and B. Suppose you want to create NOR gate, so you can just circuit to it will be given A bar. suppose you want to create OR gate, so you have to give A B. You are getting here A dot B, A plus B bar. We can create not get here right, using the source. We'll getting A plus B. So we can get AND gate also like that. So with the help of NOR gate, because NOR gate we have not also and OR also, right? That's why we can get all the basic gates.
Okay.
Okay, so I think like maybe what I'll do, like whatever the previous term question that how many numbers of NOR gates and all the things, maybe like I'll create in one Google Doc and I'll share with you, or maybe I'll solve all the question in the revision session. That will be good.
Yes, that will help.
Okay, so any
Okay,
doubt?
thank you. I mean, a little more practice and things will become clearer.
Yeah,
And but there was this like encoder and decoders. A little bit on that, please.
yeah, it's like simple question, like simple things for encoder. Okay, let me share. So encoder means so
Your screen is not shared.
okay, so what's it? Now my screen is visible, right?
Yes.
Encoder. So in encoder, what will be there? There here 2 to the power an input line will be there, and an output line will be there. Right. So suppose there are 4 2. Okay, so 4 2 encoder, right? So suppose 4 2 2 encoder. So what will be 4 2 encoder? It will be there will be 4 y3 y1 y2 y1 and y0. Like input line will be there, and there will be a1 and a0 to output line also. So these are the input line and these are the output line. So what will be the truth table? Truth table will be, this will be the inputs, output. Input will be y3, y2, y1, y0, and output will be a1, a0, right? So when A0 is 1, but all the 0, that will be 0, 0, right? And Y1 is 0, 1, and all the things are 0, this will be 0, 1. This is 1, 0, 0. This will be 1, 0. And this is 1, but that's in the 0, this will be 1, 1. Right.
There is something called column for V also. No?
Huh?
There is one more column given, no, in some questions, which is column for V.
Column B, I did not got.
This is what I'm talking about.
Okay. This is the encoder concept. And now we got it. So when like encoder is used, suppose you want to convert octal to binary, like there is a octal, is there like suppose you want to binary to octal or like suppose you want to convert. These are the given. Suppose there is a suppose we can given suppose what we can say. Suppose there are binary number is given 0, 0, 0 like that, and you want to convert binary to octal or octal to binary. Yes, someone raise hand. Which could be a question 7. Okay. I think we have discussed in the live session, right? Or
Yes.
this is like a priority encoder. So priority encoder means there will be some priorities there. So suppose priority encoder, let's write. Priority encoder. So that V means like valid output or not? That is the V means. Nothing like that. It's valid output or not? If like priority encoder means there will be some priorities there, right? Whatever that V is there. So if all are zero, is nothing priorities, right? So that means like no, it will be 0.
Yeah, that is why. So if all the inputs are 0, that means nothing is fired. So
Yeah.
V is 0, and in all other cases, V is 1.
Yeah, correct. That is priority encoder. Like priority encoder means like suppose there are in here. Okay, let's see. Here you can see that only one can be high, right? So you can see. You can see that only one can be high, right? Suppose
At a time, only one is high. Yes.
yeah, but suppose 2 is high, like 2 inputs are high. Suppose there is also high, this input also high. So that time priority encoder used. So if Y0 is more priority, then it will be 0, 0, kind of that. If Y3 is more priority, then it will be 1, 1. Like it's simple thing. Both are the simple thing that on priority is added, nothing like that. Okay. Any other doubt?
Thank you.
Sir, please share this recording with us.
Yeah, I'll share the recording.
Okay.
No, it's being recorded.
Yeah, it's recorded.
If you can share this document which you used today.
Okay, but then I have to. Yeah, maybe I'll share.
Sir, add in the calendar itself.
Yeah, I'll add in the calendar itself. Okay. Okay, so I think if you have any doubt, you can ask. Otherwise, we'll bind up the session.
Okay, sir.
Thank you, sir. Good night.
Okay.
Thank you, sir.
And good night.
Good night.